My name is Santiago Rincon, and today I'll be talking about the confidence intervals for the mean large samples. Before we find our confidence intervals, we must first find and understand these terms. First is point estimate. It is defined by the single value estimate for a population parameter. It is seen as x bar, which is equal to the sum of x over our sample. Then we need to know sampling error. And that is defined as the difference between the point estimate and the actual population parameter value. It is seen as x bar minus mu. And lastly, we need to know marginal error, which is defined as the greatest possible distance between the point estimate and the value of the parameter it is estimating for a given level of confidence, denoted by E. It is equal to E is equal to our critical value times standard deviation over the square root of the sample. Now we must find out how to use it in a question. Here's our question. Duncan Jones kept careful records of fuel efficiency of his car. After the first 100 miles, he filled up the tank. He found that the mean was 23.4 miles per gallon, with a population standard deviation of 0.9 miles per gallon. Compute the 95% confidence interval for his miles per gallon. So here we know that our mean is equal to 23.4 miles. Our standard deviation is equal to 0.9 miles per gallon. And our n, which is our sample, is 100 times. So we must compute a 95% confidence interval for the miles per gallon. How do we do that? So we must find the marginal error first. And as you see up here, this is the equation for marginal error. So for 95% confidence interval, our z-score is 1.96. Alright, so our marginal error is equal to a critical value of sigma over the square root of the sample, which is equal to 1.96 times 0.09 over the square root of 100, which is equal to 1.96 times 0.9 over 10, which is equal to 1.96 times 0.09, which is then equal to 0.1764. Okay, now we must find the sampling error. Now, we must add and subtract our mean minus our marginal error. Our mean is 23.4 plus or minus 0.1764. 23.4 minus 0.164 is equal to 23.2236 and 23.4 plus 0.1764 is equal to 25.5764. Good. Now let's simplify it. 23.22, 25.58. Good. Now our interval is 23.22 and 25.58. This is our interval, our confidence interval. So, what do we conclude? We conclude that we are 95% confident that the interval which is our confidence interval of 23.22 and 25.58 includes the true mean MPG of Duncan's automobile. Okay, so once again, we are 95% confident that the interval 23.22 and 25.58 includes the mean MPG of Duncan's automobile. And this is how we find confidence interval for a mean, large mean. Thank you, and see you next week.